All right, let me walk through the coding challenge from start to finish. So what we're trying to do is to recreate this figure and then also modify it a little bit. So let's start by getting the figure up and running. I have already done sort of one not quite walkthrough beforehand because I didn't want to give stuff away. Let me make sure I'm signed into my ebook. And then we will find figure 2.3. Now that's down at the end. It's going to take a sec to load. In any case, while that loads, here's the work I've already done, but let's go ahead and start from scratch. So I'm going to copy some of this. So my favorite line to clear everything out. Now the other thing to figure out is where your working directory is and where the data is that we're going to be using. So we're running R, and R is currently working in Dropbox /teach/fall20/390/challenges/challenge1. All right. I've got nothing here. Let's see what I've got in the files. I'm in challenge1. So I've got the data that I care about already in here in this data folder, but like I said, we're going to do this completely from scratch. Now, I've got a little bit of stuff. Actually, I don't even need tidyverse. So let's go ahead and get rid of that. DBI and dplyr, those were part of the chapter reading. I believe this is what the book had. All right. Blah, 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 blah. It's explaining stuff. We're in 2. This is good. We want to be in section 2.3, working with relational databases. So this is like important real world type stuff. A database is just one way to store data. More often in our class, we'll be dealing with what we'd call a flat file, something like an Excel spreadsheet or a CSV file. But let's go ahead and find this. So we're dealing with the PUMS data, which you know from doing the reading. The public use micro, what does PUMS stand for? What's the S? Sample, public use microdata sample. So they give some details about how they got the data, but we don't need to worry about that. We're going to be using this .rds file from the textbook. So to get that, let's go ahead and open up the data science. There we go. Open up the textbook's GitHub, which actually, just in the interest of being completely exhaustive, let's go to the page for the website for the textbook. Practical data science with typos. There we go. So you will find on the page on the left-hand side, source code and source code on GitHub. So we're going to go to GitHub, and this has all the stuff. Is this right? PUMS, there we go. All right, so we've got PUMS. We really should just download all of this because it's for the textbook. We'll be using these different bits of data at different points. I've already downloaded this twice on video, so I'm just going to download the file itself that I'm looking for. So where did I lose my textbook? There we go. Bring that over here. So library, DBI, dplyr, and rquery. I've already got those installed. So let's run each of those lines, and that will load that stuff in. I can delete this line. This line, as we've discussed, if you don't have a library installed, you don't have access to the code in the rquery package or whatever package, you run install.packages and then the package name, and it will pull down from the internet the relevant code so that you can use that code. But I've already got it on my computer, and I can tell because when I loaded rquery, I didn't get any errors. I did get some messages, but we don't have to worry about those messages just yet. Now, The other thing I should do is immediately save my work. So I am in Challenges, Challenge 1. I've actually downloaded all the PUMS data into this folder already. So let's just call this Coding Challenge 1 Walkthrough .r. Cool. .r means that it will automatically recognize any syntax, and that just makes it easier to pick up on any errors you might have in your code. So I've got this stuff. Let's put these guys over here so that I can get both at the same time. We got this. All right, so the important thing is going to be dlist. Without dlist, we're not going to be able to do any of the other stuff. Now, dlist is just an arbitrary name, but what really matters is that we get this file. Now, if I got it here, sample.rds is in data. Tab autocomplete, by the way, is your friend, and RStudio makes it a lot easier to fill in blanks, so you should be reaching over and tapping your tab key quite a bit as you're doing this stuff. All right, so we load in dlist. Now another thing, again, with this line, this empties everything out. So I've got this environment is empty message up here. That's a good thing. That means I'm not going to mix up what I'm doing here with something else that I might have done somewhere else. So I load this in. It's taking some time because it's a big file. And again, just to show you how we might do this explicitly, we're looking for what? PUMS sample.rds. So if we really wanted to do this the slow way, we could navigate to this and then go to download and then save file. 13 megabytes doesn't sound like a whole lot, but there's a bunch in there. So you hit save. And then we can go to our downloads, check the folder that we've got that from, copy that over to wherever it is we're working, drop it there, and now we've got access to that data. So now I should actually even be able to do it without the version that's hidden in this data folder. So if I do PUMS sample.rds, ooh, still looking at the one in data. Let's see if it works this time. No error code so far. So a common error you'll see in a situation like this is such and such object doesn't exist. So if I were to run it like that, I put in a typo. The version of the file spelt samples doesn't exist, so it says no such file or directory. So let's undo that. Now, nice thing that it just did, it had an error. So if we were, say, trying to make an object called dlist2 and we get this error and we don't create dlist2, in the case where we already had dlist and we tried to overwrite it with this code that's not going to work, it left what we had already. All right, so that version should work. Give it a sec to load. And then we got this other stuff. So DB gets DB connect RSQLite. This is going into the RSQLite package, which you might need to install to get this to work. SQLite. SQLite is just one type of database software, and it looks like we are loading it into the memory. Now, I don't work with databases a lot, so for me going through this, I've seen code like this, I've run code like this, but really I'm just kind of following along and trusting the textbook and then dealing with errors as they come up. Speaking of which, there was a nice little quote. I saw there was a good thread on Ask Reddit, what's an industry secret from something, something, something. And one response was, knowing how to research the answer to a question is at least or even more useful than knowing the answer to begin with. I made a living in IT for a decade with that mindset. This is definitely a skill you pick up in a programming class. If you ask anyone who's done any sort of programming what they think about Stack Overflow, it's a godsend, right? It's how you solve your problems. You run into a problem and you check Stack Overflow. And actually, while we're here, let's really quickly Google something. Stack Overflow, how to ask a question. How to ask a question on Stack Overflow, on WikiHow. How do I ask a good question? So this is a really important post, important enough. I'm going to dump it on the screen here. stackoverflow.com/help/how-to-ask, separated by hyphens. Oops. Comment that out. We don't actually need that, but look that up. This is really valuable. This is valuable not just for this class, but if you got a problem with your car, you got a problem with something, following these basic procedures is how you get someone to help you, right? Law of demand. As the price goes down, you get more of something. If the question is, how do you get more help? You lower the cost of giving you help. And this is all about how to lower that cost to the people you want to help you so that you can get more help from them. All right, so back to here. We create DB. So this is really just holding on to information about a database we're creating in RAM, right? So it's just a temporary database. Sometimes you will need to reach into a database file, or you'll need to reach into the database at your work. This is kind of giving you a taste of that for the purpose of practice working with relational databases. So the data we pulled out of DList, this had all the actual stuff, and then we're going to feed it back in. Let's make sure we get this. So you DB write table into the database called DB. We're going to do the personal data. I'm going to skip the household data because what I want is really just to get to that figure. But I would definitely encourage you to go back. If you're not doing this while you're watching this video, go ahead and pause, open up RStudio, follow along, and do like I'm doing, type it out. I might get lazy later on and start to copy and paste, but only to save time for the video. Really what you want to be doing is going through this and manually typing it out, because that's going to help load it into your brain. I'm also going to make that full screen. That was Control-Shift-1 to make the script full screen. Control-Shift-2 makes the console. Let's go back to the script, just so I can make better use of the real estate on my screen. All right, so I'm going to skip the household data. This line removes the DList object. Let's actually see what we got. So do I need DList? I don't. Not once I do this. So I run this line. Let's forget the full screen. Let's just squeeze this way in. And I'm going to make this small. That'll be fine. All right. So now what we've done is we've taken this thing DB, this database that currently exists in the memory, and we've just loaded some data into that. I will go ahead and actually do the other one while I'm here. The household as .dataframe DList $ SS16 house, and then remove DList. Cool, so now I've only got the DB object left over. This line I don't actually need, I think. What's the next line we're going to take from here? We're going to read out of the table into this new object we're going to create. So this other stuff I don't strictly need, and I didn't really need to remove DList. It just reduces the clutter, right? So we're kind of cleaning up as we go. I'm going to skip all this stuff. This is, nice summaries, but not essential for the challenge itself. DPUS is DB read table out of DB, and we're going to look for the table called DPUS. if you want to learn more about SQL, we'll touch on some of it here. We'll see a bunch in DataCamp if you want to go into that. That's probably the most sensible place to start, but there's a bunch of information all over the internet. Dealing with SQL, this is something, by the way, the Econ Board of Advisors, our external advisors, we had a meeting with them, I think in the spring, sometime in the distant past. Everything feels a million years ago. But when we could meet in person, it was pretty common on the advisory board, people out in industry and government. What they want you guys, econ majors, to know is things like this, the ability to work with SQL, Python, R, these sort of technical things. But SQL is a good investment. Learning how to deal with that is going to open up your options. And again, the key isn't knowing what to do, it's knowing how to find the information that tells you what to do. All right, so we've created DPUS, or we're about to. So we'll see that pop up over here. Again, it's taking some time. Part of that might be I'm using RAM to record this, so my computer is being a little bit slower. Cool, so we got that. Now, this line I am going to copy because that's just a little bit more than I want to type without gaining a whole lot of understanding. So all we're doing here, we're using our square brackets to take out of DPUS. So DPUS, we got a whole bunch of columns. We got all these different things. What was it, like 200 columns? That's way too many. So what this does is it gives us all the rows and then a comma and then these columns, the columns in this vector that we get from the C function. So if we take this, let's go ahead and run this just so you can see what it looks like. That's just sort of these things put together. So that R, when it sees this, it knows we got 8 things. The first one is age P, the 7th thing is sex, the 6th thing is school, and yada, yada, yada. So here we say all the rows and then these columns specifically. And there are other ways we could do this, but we'll stick with what's in the textbook. We don't need to make things more complicated than necessary. And then our for loop. So we're creating a temporary variable called CI in these particular variables, age P, perm P, pince P, and work hour P. I think this is probably P for personal. Curly braces, DPUS, double brackets. Double brackets is a thing you see with lists. So there are different data types in R. Lists, vectors, data frames, matrices, strings is just a block of text, a numeric is a number. So a data frame is strictly a list that contains other lists, and those lists basically are a variable name and then a vector of variable values. That's abstract and weird, and you don't need to know that right now. You'll pick that up in time, but learn to pick up on cues like this. Double bracket, you should be thinking list. So you might, if you run into a problem, that should give you at least some hint of where to start. Oops. Square brackets for CI. So the structure of this for loop, we create a thing called CI. Initially, it's going to be age P, and then we say DPUS, give me the age P element. So let's just explicitly push this through as list, just so you can see how this, oh, way too big. What do we get with head? Still too much. Let's see, what do I want? I want the dimensions of DPUS. We got 100,000 rows and 8 columns. So if we go head of DPUS, we'll get those first 6 rows. So these are the variables we're dealing with, and what we're about to do is make sure that things like under 1 year get converted into a number rather than this text under 1 year. right? So you and I as humans read that and know exactly what it means, but the computer just sees a bunch of ones and zeros, and it says these ones and zeros are some sort of a character value. They are something like bachelor's degree that you couldn't possibly add to regular high school diploma or divide or raise to the power of in any meaningful way. So forcing it to be as numeric, that should give us some sort of an error, but 6 is going to be turned into 6, right? So here, if we see an error, then we should just expect this is something weird, right? But 11 will be 11, and that's essentially what we want here. So again, what am I doing? I'm trying to look at DPUS as a list. So I'm going to create a temporary variable called t, which is the first 6 rows of DPUS. And let's just go age p, right? So here we're looking at 06, 08, 12, 11, 08, under 1 year. We're getting that column out of this temporary thing we made called t. This is what t is. Some of it's behind me. So when we say get the first, let's get the second element in t, that's going to give us this list of things. And let's go look as list t. Here we go. So when you work with lists, you'll see stuff like this. So here's just another way to visualize on the command line, another way to think about this data. We've got this thing called t, and $age_p is this vector that contains these things. $cow is these things. Again, what's going on is we've got some data structures, and those data structures we can do different things with, and different data structures might be easier to deal with in different cases. But what we need to know for now is that this will work for us. So we run through this for loop. We got some NAs, which is fine. But now if we look at head of DPUS, we see that under 1 became an NA. And the other ones, we got a bunch of NAs. We still have these weird NAs with the triangle braces left over from importing the data. Let's go ahead and remove a couple things. I don't need T, that was just temporary, and I don't need CI, that was also temporary. CI right now has the value WKHP left over from that for loop. Let's just get rid of them by explicitly labeling that as list. There we go. Cool. Our workspace is a little bit tidier. Okay, so we did that. DPUS $cow takes string trim of DPUS $cow, trimming it down to only 50 characters. This isn't terribly essential, but hey, I've already typed it, so might as well. All right, so now we are looking to update some stuff. I'm going to get into copy pasting, right? So this, again, it's just a vector. Not super important. Just so I don't lose track of where I am. So target employee levels, that's fine. This is going to help us deal with factors. Complete cases, we're looking at that. Let's look at just, if we run complete, we're going to get 100,000 true falses. If we run, say, complete in square brackets from 1 to 50, we're going to get the first 50 values there. Let's throw in a comma and see what error we get. Incorrect number of dimensions, because complete is a vector. Is that right? So if we ask what is complete, we get a logical vector. So when we put in that comma, it said you're looking for a second dimension to something that is a one-dimensional object, right? It just goes in a straight line. Cool. All right. So we've defined the complete cases. Can complete.cases. That's worth taking a quick look. Returns a logical vector indicating which cases are complete, i.e. have no missing values. Let's look at the head of complete. False, false, false. And that makes sense in light of what we saw. Those first 6 rows, we had a bunch of NAs. So none of these particular examples were complete cases. If we look for, say, DPUS, and I'm going to filter for complete. Let's see if filter will work that way. And then I'll sample n cases, and I'll just look at 10 examples. Cool, that worked. So let me show you what I just did. Here, I'm just kind of fiddling around with the data to see what's there. So I took this DPUS object. Let's go and full screen this again. So DPUS, this is our data set. We got 100,000 observations of 8 variables. I said, let's filter to the cases that are complete. So filter means we're looking for particular rows, and complete basically tells us the first 6 rows are not part of what we're looking for. We're only looking for the rows that correspond to a true value with complete. Now let's try and break this. So let's say instead of the entire vector of complete, we just look for, say, the first 1,000 examples. What do we get? We get an error, problem with filter, input must be of size 100,000 or 1, not size 1,000. So since we're trying to filter out of 100,000 rows, either we give it some condition, like give me the things where age is greater than 11, age greater than 11. Oh, come on. Let's try like this. There we go. Sometimes you need to put stuff in quotes. So here we've got a condition that is length 1. It's just check this thing, and if that thing passes, then give us that row. Up here, I gave it 1,000 things, and there it says, well, 1,000 things doesn't make sense to look at. Whereas before, I said, here's 100,000 things, give me of the 100,000 rows, give me the ones where we get a true value for complete. All right, let's go back to here. So we've got this idea of complete. So these are the rows we want to keep where we're not missing data. Let's see how much we've got here. Let's try and sum complete. We've got 52,000, so a little more than half of our data is complete. We might want to know why the other half is incomplete, but for now, we're not going to worry about that. We're just focused on just a particular task of getting this figure recreated. So we should expect to lose a bunch of data. Now we're creating a standard worker. With is a neat little function, so we say with DPUS, the alternative to this would be really annoying. I mean, this is already kind of an annoying block of code, but if we said like this, DPUS $PINCP, that's what we're going to need to make this work. Now we got a stray parenthesis, so we need to go through and manually paste this over and over again, which is an opportunity to get all kinds of typos, to forget something, like I was about to here. I'm going to forget this intentionally just to show you guys what sort of error we run into. So, standard worker, let's see what we get. Error, pern_p not found. Because there is no such thing as pern_p over here in our workspace, but there is such a thing as DPUS $pern_p. So when we run that, we're able to create this logical vector, which again tells us we're not looking at those first 6 rows. Let's see how many rows we are looking at. Standard worker. Oh, come on. Some standard worker. That seems to be fine. Why is it not working for me? Well, let's try standard worker times 1. Still no? Standard worker is a logical vector. All right, whatever. Sometimes it does what I want, sometimes it doesn't. But in any case, with allows us to avoid doing all of this. So in a case like this, it's a lot easier. When you use something like filter from the tidyverse, it will also kind of be implicitly doing this. You'll say filter DPUS, or the way I did it before is I piped DPUS into the filter function, so it was taking DPUS as the first argument, which is what data are we filtering? And then the next argument was the condition where we're looking for age to be greater than 11. Is that right? Oh, you know what? There's no such thing as age here. Let's go ahead and rerun that. Where is my filter? Right, so here's why that didn't work. Oops, that's the wrong spot to put that. Let's put this to console. So when I run this, I get the error age not found because there's no such thing as age in here. But if I were to go age p and run that, that time it worked. Right, so here we're essentially doing something very similar to with, right? We're implicitly saying with DPUS, look for where age p is greater than 11. Right, that's what's going on in this filter statement. All right, cool. So we got a standard worker. I'll use the one in the textbook. And then we're saying DPUS, we want, well, let's start here. We're going to look at the dimensions of these things. So we'll say the dimensions of DPUS, where the rows correspond with what is incomplete. We get 52,000, just like we should. And then for standard worker, we get 37,000, which we should. And then if we check to see if we're getting both of them, let's actually try this. Let's go standard worker or complete. Still 52,000, a little bit more. So what that means is most of the complete rows are also standard worker rows, right? Workers who are civilians who are employed and make less than $250,000, but more than 1,000, and who work more than 30 hours a week and are more than 18 years old, but less than 65 years old. So here I said, give me all the rows in DPUS where complete is true, or that's what this little bar is, or the standard worker value is true, right? So are they a standard worker or do they have complete data? And we get a few more observations than we do when we're just looking for complete data. When we look for the standard worker data, we got 37,000. And when we see when they're both true, then we get 37,111. So again, standard worker isn't catching everything. There's an imperfect overlap between these. I'm going to do something else here. I'm going to call this dpus.back gets DPUS. That way I've got the DPUS data. If I screw something up, then I don't have to go back and reset everything. So I'm overwriting DPUS, but I've got this backup version of it saved. So DPUS is now all the cases with the complete and standard worker, and drop equals false. Double question mark is a good way to search for stuff. Drop. Help pages, crayon, dials, drop response, drop features, drop NA. Should be looking for something in base. Now, this is also sometimes a thing that happens. You get some code that works and you don't look much closer at it. Base, drop, here we go. Delete dimensions of an array which have only one level. So an array, this is again a data type. Matrix is a data type that is a subset of the type that includes array. If X is an object with dim attributes, then drop returns an object like X, but with any extents of length 1 removed. All right, so we're saying drop equals false. Wonder what happens if we did drop equals true. Let's try it. So right now we've got 37, 111. If we do this, didn't change the results. Let's start with resetting. So we've reloaded dpus.back into dpus. I'm going to try running this with drop equals true. No difference. All right, so that didn't turn out to matter. But in any case, we'll stick with what the textbook has. No advanced degree, we're asking if you've got an NA for school, or you do not have one of these values in the school column. So again, if we look at the head of DPUS, we'll see under school, 1 or more year of college credit, no degree. That's not on this list. That person is going to be converted to no advanced degree, right? Which later, we're creating right now just a Boolean vector, and then we're going to use that Boolean vector to change all of the rows that correspond with that to no advanced degree. So let me just show you that. DPUS, school, no advanced degree. Here we had someone with an associate's and then someone with no advanced degree. Again, that came from 1 or more year, grade 11, grade 12, 1 or more year, associate's degree, GED or alternative. Associate's degree we are counting in this analysis as an advanced degree. And so that stays associate's degree, but the other things get converted to this string value, no advanced degree. All right, I'm just going to follow along since I've already copied this. And then this save RDS, this is another way to back up your data. So have I got this? DPUS standard employee. So right now I've got something from the 16th that was 340 kilobytes. Let's see what happens when I overwrite that. 194 kilobytes. I might have left something out. But in any case, we're not going to load that back up. Let's see what we've got when we run a summary. We've got still some NAs on age P. That doesn't seem right. 37, that should be fine. I'm just going to rerun all of this. 340.7. So when I ran it with drop equals true, something did change. I had less data in this RDS file. And when I run summary DPUS, notice now I'm not getting those NAs. All right, I'm going to be lazy and not look too deeply into what exactly was going on there. I think maybe what it was dropping was this ESR variable. Since we filtered to only have those values as part of our standard worker, it might have just been saying, hey, it doesn't really matter. Whatever. All right, let's keep going. I don't need this, so I'm just going to comment it out. Let's go back to here. And let's put this way. All right, so we were here. We don't need to look at this stuff. You guys did this when you read the book. But here we've got some important stuff. So D gets cbind. We're going to combine some columns. Data frame of where school equals as.character DPUS $school. Strings as factors equals false. Base R will often convert strings to factors. So instead of saying no advanced degree, it's going to sort of create some categories. That might be category 3. So it'll save it as you're in category 3, and then you'll look up what does category 3 correspond with. R is doing the lookup. And that makes sense in some cases, but we'd like to sort of push that off as far as we can, right? Leaving it as characters makes it easy. If I look into the data, I will just see what is there. I will just see no advanced degree, right, or what I'm expecting to see. All right, so we are binding the data frame where school, so we're essentially creating this data frame. Let's go ahead and run this down here. So we got this data frame. Let's actually just look at the head of that. And we've got a data frame with one column called school that is the string value from DPUS $school. And then I just said, let's look at the first 6 rows to make sure things seem fine. So that we are combining with model.matrix tilde school out of DPUS. Let's see what happens when I run that. Oh, whoops, that ran the whole thing. RStudio does a nice job of, in this case, I said, run this bit of code, and it said this code is inside this code, so it ran the whole thing for me. Let's just try model.matrix tilde school DPUS. What are we getting? Let's see what this is. Matrix, array, structure, vector. We'll call it T, temporary object again. T, 1 to 4, matrix, array, structure, vector. So let's look at T1, T2. Oh, that was a silly mistake. I included this pipe, so I was getting the results of is as T. So T, large matrix. Got a whole bunch of stuff in here. Let's go ahead and use view to check that out. So we got intercept, we got these values. This is a cool little thing. So this is essentially creating a one-hot mapping. So this first row, and I mentioned this in the other walkthrough, this we've kept row names. So this was the 7th observation in the original data, which we could check against dpus.back if we were less lazy. This person has 0 associates, bachelor's, doctorate, master's, or professional degree beyond a bachelor's degree. This person, number 20, has a bachelor's degree. So this is just creating a 1-0 value out of this variable. Cool. That is worth keeping in your back pocket. That's a nice little trick. More often, I would just say treat school as a factor and let R automatically generate dummy variables for me. But hey, this works, so that's fine. So we've created this object D. This is getting kind of messy. I'm going to run the whole thing. It's going to take a second because it's going to clear everything out and reread this big data set. But I want to make sure that my code is working well. So if it gives me any errors, then I know I've got to fix something. If it doesn't give me any errors and I get D as this 37,111, let's call it 111 observations, if it works fine, then great. That means that everything above line 70 in my code should be okay. All right, so while I'm waiting for this to catch up, I'll go ahead and start typing out the other stuff. So I want D $. This is slightly annoying. We want single quotes, not double quotes, on intercept. Really easy to make a typo there. So we're saying that D intercept thing, this first column, we're going to give that a different value. That value is going to be null. Cool. All right, so finished sourcing. We got errors, some NAs by coercion. Object T not found. That was because when I was running remove, I was removing, well, it took care of CI. I didn't need T, so I'm just going to leave it like that. So that if I were to resource it, I wouldn't get that warning. It was just warning that I was deleting something that didn't exist. And that's fine. All right, so I've done everything to here, and now I've got D intercept is null. Let's look at the head of D. School, no advanced degree, school associates, bachelor's, doctorate, master's. It looks like it just dropped that. I think it might have. Let's run this again. So we get this intercept, and then when I say intercept is null, null says nothing. So I say this list within this D object. So D is this list of variables. There was a variable called intercept, and I said that's nothing at all, and it looks like it just dropped that for me. So I could have said D is going to be D, and we're going to filter, we're going to remove this intercept term. Whoops. All right, there we go. All right. Don't need that, don't need those. Let's see if this works. Of course. All right. Filter, not filter, select. Let's try it again. So I selected out intercept. Should be the same thing as here. I'm going to do my version just for kicks. I'm going to put that on one line because it doesn't really need to be. Actually, you know what? I'm going to even forget the pipe. This is the same code, just without that pipe. So I'm just selecting out of D. I'm removing the intercept. So minus intercept should do the same thing as what I did here. And let's just contrast string structure of D. So here our results look pretty similar, although they have 41,000 observations. There's something weird going on here. Maybe they were using a different version of the data. I'm not going to worry about that right now. Again, the point is not this particular analysis, but just the assignment. Here we go. I don't really need this. I don't need to create this table, although this is something that you should have been doing while you're doing the reading. A neat little breakdown of what we've got here. And then, here we are. So actually, you know what? I didn't even need all that stuff. That was a digression. All right, so let's just focus. WV plots, we're going to use the scatter hist. We'll take the data from DPUS using age P, pints P. Let's go ahead and actually take a closer look. Our arguments here are the frame. So DPUS is our data frame. Our X variable is age. Our Y variable, I think, is principal income. So here we don't need to say Y variable equals principal income. We're just letting the order dictate how WV plots scatter hist interprets this. Our title, right? Title is our next one. And then notice we got a ... That lets us pass other stuff into this. But basically what it means is everything past title, we're no longer using positional indication of what argument is being passed in. So we don't need to say the frame is DPUS, but we could. It was enough just to say the first argument is the frame and the first argument we're making is DPUS. Once we get past title, this ... might let us pass in something like na.rm, right? Which might be useful. And then if we wanted to say smooth method equals something other than a linear model, then we could change that. Or if we wanted to estimate significance, we could set that to true, but we would have to explicitly call estimate significance. Cool, so let's go ahead and just keep going with what we've got. Expected income as function of age. Smooth method equals LM. Let's check WV plots, scatter history, scatter plot with marginals. It's giving us histograms on the margins of the graph. And then we're getting some estimated distribution. And then, all right, cool. So smooth method. Does it give us other ideas of what we might put in there? Smooth method. Let's try with, let's try auto. Let's see what we get from auto. And then point alpha. Alpha tells us about how see-through something is. So you'll notice that we got some amount of transparency, and then here it looks dark because we got a lot of points on top of each other. So here, 0.025, so 2.5% non-see-through, right? So we're not putting a lot of ink down on the graph for each individual point. So to make a dark spot like this, there has to be a lot of data there. Just to show you how that might turn out differently, if we said point alpha equals 1, let's give us some space so it shows GAM. We can look up what that is. Auto, GAM. Right, LM is linear. LOES is going to be local something. It's going to look kind of squiggly, but it's going to match the data pretty nicely. But it's really just kind of giving you a representation of the data. It's harder to make an inference from a LOES model. All right, so auto, did it give us the plot? There's our plot. So notice with alpha equals 1, it's pretty rough. If we said alpha equals 1/40 and run it again, it's taking some time to run GAM, whatever that is. Let's go ahead and just look that up. Our GAM model. Here when we say 1/40, it gets more faint, and we can see that there's not much data up at the top here, but there's a lot of data down below. Generalized additive model. A generalized linear model in which the linear predictor depends linearly on unknown smooth functions of some predictor variables. So it looks like it's giving us something linear. Let me just show you a LOES, if it'll work. So we're just chunking together additive things. I think that probably makes sense if we were going to throw on more than a couple dimensions here. Non-parametric means. All right. Huh. Not going to worry too much about that. But in any case, what we've gotten to this point, and it is taking some time because the LOES is sort of giving us, a lot of detail. It's not compressing the data as much as, say, a linear model does. Right? Notice, just a quick digression. What a linear model is fundamentally doing is it's taking all of this data, these 37,000 observations, and representing it as a line. That line, plus some statistics around how that line relates to the data, that's basically giving you a condensed representation of this entire data set. It tells you older workers make more in this data set. With a LOES, we're going to get something a little bit more wibbly-wobbly. It's going to look like it fits the data better, but it's also going to take more numbers to describe the results of a LOES operation. Let me go find what LOES specifically is. This is something you'll see in ggplot when you make a plot. The default, I think, is a LOES regression, which again is giving you some sort of a representation, local regression, giving you some sort of a condensed representation of your data, and you hope that that condensed representation allows you to infer something about data you haven't seen before. So drawing a line of best fit just says, I think that, if we got something with a value of 40 over here, our best bet is that it would be about 12 for whatever this y variable is. Right? That's a pretty good estimate. And if the data tends to look like this, then yeah, that's quite a good estimate. if you're looking at something, now, are we getting an error? Let's try putting this in a separate window and see if it works. It might not. Now it's not working. All right, whatever. You'll see LOES later on. Local polynomial regression, locally estimated scatter plot smoothing. Right, so essentially what that's doing is it'll fill in something that fits the data, basically by looking at what's the relationship in this really narrow range, right? So in this neighborhood, we have a line of best fit like this, but in this neighborhood, the line of best fit is horizontal, and in this area, it looks to be downward sloping, and you basically are estimating piece by piece such that it connects to the last piece. It's a clever way to make a line of best fit, but it's not necessarily something that's going to be easy to work with. And a linear model is going to have just a lot of nice features to do with other things, to do with other aspects of this. All right, so let's make this a linear model. Linear model is also running faster, which is nice. If you were, say, working for Amazon and you had to do this analysis in a way that it could be applied to 1 billion customers all at once, you're going to have some reason to go for something that's simple but fast, even if it's not as precise as what you might get somewhere else. There's another issue called overfitting. We'll talk about that later in the semester, though. In any case, what we've done to this point, we've pulled in the data. We've set up a script that we haven't been saving. Let's save that now. We pulled in the data. We followed along with what the textbook was doing, just line by line. It was just copying code, and we finally got to this point where we have this plot. Maybe we have this plot. I don't have another window. All right, whatever. Let's try it one more time. So we've got the plot, and now we want to think about how we might change this. So let's get rid of D. Let's look at what we've got in DPUS. We've got these variables. Let's go really quickly. I saw somewhere in this PUMS folder the README. Here we go. This will give us some details about what these are. No. It was somewhere in there. All right, well, README scatterplot 1. Data dictionary, this must be what I'm thinking of. Let's view this file. There we go. So field name, area, division, note, field keys, state, electricity, housing, laptop. Man, there's a lot of data in here. Let's look for cow. Class of worker. All right, class of worker, that's kind of boring. Let's look at what ESR is. Employment status recode. We got school, we got sex, we got work hours. Let's look at work hours. So let's try and think about how work hours change. Update this so it corresponds as a function of age. So we plug that in. And maybe we'll get a plot. Maybe we don't, because this is just lagging. Oh, well, it at least did the thing. Let's try this. I'm going to say png temp.png. It's going to be kind of small, and then dev.off. Let's run this. Look in files. There's no such thing as def.off, dev.off. There we go. And again, let's get our working directory because I've forgotten where I am. I should be in challenge 1. Whoops. Challenges, challenge 1. And what did I call this? Temp. Temp. There we go. So there is the plot. We can see that older workers, it looks like they work a little bit more, but it's kind of really hard to say. The data here, we can definitely see a lot of people just report 40 hours. A lot of people are reporting on other sort of even amounts. They either say, I work 50 hours, I work 60 hours. Very few people are saying I work 62.5 hours. But in any case, we can see that we got a good amount of young people working a lot. We got a good amount of old people working a lot. It's a pretty insignificant looking trend. Let's just check this really quick as long as we're here. Let's make a model. So our model is going to be a linear model where we are predicting work hours as a function of age p, where our data is coming from DPUS. We run that, and then we ask for a summary of our model. And here's what we get. Statistical significant, but an adjusted R-squared of almost 0. So it does look like as you get a year older, you expect to work an extra 5% of an hour, I guess. What's 0.05 times 60 minutes? An extra 3 minutes per week for every year older you get. But there's a lot of variation that we're not explaining with this regression. So even though we have a statistically significant result, 3 minutes is tiny, and we got a pretty small adjusted R-squared. So whatever it is that's driving how much people work, it doesn't really seem to have very much to do with age, right? We explain less than 1% of the variation. But that's jumping ahead. Maybe that helps you for 380 if you're in that. What matters for here is getting to this point, just copying the code from the textbook. It seemed like the most difficult thing people were having was just this first line, getting the data in. But once you got it in and you follow along, if you don't get any typos or you catch them early, then we get this. So let's just source this one more time, see if it gives us any errors. If it gives us errors, we'll go back and fix those, and then we can submit this. I got 1 and 2.5 submissions. I didn't get submissions on this. So you guys are playing the strength in numbers strategy, which for this week we will allow, which means make this work. You've stuck with me for an hour now through this walkthrough. If you've been pausing and typing stuff into R as you've been going, you should be set. If that hasn't been the case, jump onto the class Discord and let me know so that I can start working with you to fix that. All right, I'm going to stop and upload this to YouTube just as soon as this happens. We got a couple warnings, and that we had way back. I think that was in here. This was when we changed something like an age of under 1 year old into a number. Under 1 year old doesn't nicely convert to a number for R. We could explicitly tell it to convert under 1 year to an age of 0, but it doesn't really matter since we're going to be filtering them out anyways. All right, cool. I'm going to stop, and I will see you guys in a little more than an hour.